These are your 12-8 notes on translations of trig functions. So in this section of notes, we are going to talk about horizontal translations, moving to the left and to the right, and vertical translations where we move up or down. The first one is the horizontal translation, which we call a phase shift when we're talking about trig functions. So a phase shift is when we move an entire sine or cosine curve to the left or to the right on the coordinate plane. The form of the equation is we subtract an h value. H is our horizontal movement. It has been all year. So the change is going to be the same whether it's sine or cosine. We are going to disregard the tangent because we are not dealing with tangent functions in this class. And the form says minus h. So notice it's inside parentheses with theta. Theta is our x coordinate. So to change whether we're going to move to the left or to the right on the x coordinate or on the x-axis, we got to have that change with theta, the degrees. If h is greater than 0, it's basically saying that h is positive, we're going to shift to the right. And if h is negative, then we're going to shift to the left. Even though if h is negative, the equation itself is going to look like a plus, because when you plug in a negative, the negative minus h becomes plus h. So if you look at these graphs, they are going to do the same thing. I'm showing you in sine and in cosine. So what I would suggest is a highlighter or 3 highlighters, 2 highlighters if you'd like. You don't have to highlight the parent function, and then kind of highlight the equations as you go as well. So the blue function is the parent function. So I'm going to give you guys some numbers so you can wrap your brain around it. So the blue function is just a normal sine curve. Period is 360, amplitude is 1. They're not changing any of those things. If you look at the red graph, in comparison to the blue parent function, it moves to the right. It looks like it's shifted to the right. And so let's give the red graph the equation y is equal to sine, parentheses, theta minus 30 degrees. In that case, the h value is a positive 30 degrees, and so we're going to shift to the right. So if you want to write that down and then highlight it in the same color that you highlight the red graph, it'll help keep things straight. Excuse me. The green graph shifts to the left of the blue graph, and that's because the phase shift is a negative value. So let's put y is equal to sine, parentheses, theta plus 30 degrees. And the plus 30 is really telling us that the h value is a negative 30, and so we're going to move left. Again, highlight that statement along with the same color as the green graph. And so the same thing goes for cosine. Cosine, the blue graph, is the parent function. Y is equal to cosine theta. The red would be y is equal to cosine theta minus 30. And the green would be y is equal to cosine theta plus 30. I apologize, my board is acting up. Then we have what's called a vertical shift. And so the vertical shift is pretty straightforward. Vertical shifts the entire graph vertically. And so that's a k value. We use h and k just like we did in quadratics. So the h value is your horizontal, h horizontal. K is on the outside, like your y value. It's the outside y change. And so you're going to add or subtract that, not from theta necessarily, but after theta. And so once again, the colors coordinate the same way. So this isn't going to be a degree shift. This is like a +1 or a -3, that sort of thing. So the blue graph is your parent function. Y is equal to sine. Give me 1 second. I hate this stuff. All right, so hopefully I fixed my graph or my smartboard. So the blue graph here is the parent function, y is equal to sine theta. The red function would be like a shift up maybe 2 units or 3 units. So we'll say y is equal to sine theta plus 3. Notice I didn't put parentheses around the plus 3. I'm adding 3 after I take the sine of theta. Where in the degrees, we've added the degrees first, then took the sine. My board is still acting up, so I apologize for the writing. I'm going to just kind of power through. Y is equal to sine theta minus 3 for the green. It went down 3 units instead of going up. On the cosine, same thing. Color coordinate your graphs. The blue is just the parent function. The red function is saying that we added a certain amount after we took the cosine of theta. And the green is a subtraction, so y is equal to cosine theta minus 2. Now, when we shift things up or down, it changes the middle of where we actually oscillate. So oscillation is like going back and forth, like a fan that oscillates, or a graph. A sine curve goes up, and then it peaks, and then it valleys, and then it peaks, and then it valleys. Same thing with a cosine. And so up to this point, our midline was the same as the x-axis because we never shifted upward. When you move up or down, it changes our midline or our middle line. For parent functions, it's just the line y equals 0, which is fancy for x-axis, okay? But the midline for any other graph, if you have a k amount of units, it just becomes y equals k. If you remember way back from chapter 2, horizontal lines of the form y equals something. Now, if this was 2 units, let's say, and the amplitude for fun, let's say, was 3 units, we do not go up to 3 for our max and down to -3 for our min. We would actually go up 3 units from 2, which would take us to 5, and we'd max out at 5, and then we would go down 3 units from 2, which would take us to -1, and that's where we would minimize. So the amplitude is still the same. It's the number out in front, the A value, but how it affects, you don't see a 3 on the graph at all. You go 3 up from the middle and 3 down from the middle. So the next slide, I'm going to show you how to graph, the order in which we graph things, and then we'll do a couple together. It's really important that you follow these 4 steps. Some of your graphs may stop after step 3. It just depends on whether you're going to do a phase shift or not. We do vertical shifts first, and then we do phase shifts at the very end. So step 1, you're going to do your vertical shift, and you're actually going to move the midline. So let's say this was step 1. This is my midline. We create our new midline. And so that's y is equal to k. Step 2, we calculate amplitude, and we bring in our maximum and our minimum dotted lines. So step 2 involves amplitude. Now step 3 is your period, and so you break up your x-axis into your fourths or whatever it may be. And then step 3 could be just graphing it on the new midline. So we just raise this graph up to the green line. If there is a step 4, though, I want to show you what happens if there's a step 4. So let's say I'm going to graph a sine curve. On the green line, I'm going to put my middle lines, my beginning, end, and middle. I'm going to give my peak. I'm going to give my valley. But I'm not going to graph this as a solid graph. I'm going to graph this as a broken graph, and I'm going to refer to this as my guide graph. It's going to guide me in my phase shift. So it's just a nice, quick little sample of the parent function, but we don't want to have it solid. And by breaking it, that's our little note mathematically that it's not part of the graph. It's just helping us graph. So this is step 3. Step 4 is applying the left or the right translation. So when I translate those beginning values a certain amount, just sideways, and you want to try to be consistent with that. But notice I went to my 5 original points that we usually use. You try to keep that distance the same, so you establish if it's 45 degrees or 30 degrees using your scale. This looks like it was probably like a 15 degree, and I apologize, my distances are not the same. My board is acting up. And then you create the solid graph from there. Okay, so that is step 4. Do not try to do a phase shift without a guide graph. It doesn't work. And I'll mark you wrong anyway, because I need the guide graph to help me quickly grade your paper and see. I can quickly look at this and tell that the purple step 4 graph is to the right of the guide graph. So it helps me out as well. All right, let's try a couple of these. So the first one is just a vertical shift of 4 units. So my amplitude is 1, nothing changes there. The period is 360, there's no B value, so it's 1. The phase shift, there is none. And the vertical shift is 4. So that makes my midline y equals 4. So I'm going to put that in the middle up here. I'm going to label it 4, so I know that I went up 4 for scaling purposes. And then since the amplitude is 1, I'm going to go up to 5, and I'm going to go down to 3. And I know that those are 5 and 3 because over here I'm going to label them 5 and 3, up 1 and down 1 from the middle. I need to label the period 360, which is on the scale, so 360, 180, 90, and 270. It's a sine curve, and so I'm just going to do all the graphing on the actual green line. And so I don't have to do a step 4. I'm not going to do a phase shift, so I don't need any dotted graphs. I'm just going to have one graph here. So my sine curve starts at 0, 4. It ends at 364, and it's in the middle at 184. Goes up at 95, and it valleys at 273. And there is one period of this curve. Okay, next example, I'm going to show you a phase shift. So again, very simple as far as the other parts. Amplitude is 1, period is 360, and there is no vertical shift. But the phase shift is 45 degrees right. It's a positive 45 degrees, even though it looks like a minus. So the first thing we're going to do is bring in our, actually we don't even have to bring in the midline because it's the x-axis. So my x-axis serves as the midline. My amplitude is 1, so I'm going to go up to 1 and down to -1. Break my max and my min values. Bring in the period of 360, 180, 90, and 270. This is the cosine function. And so I'm going to graph the cosine function, but I'm going to graph a guide graph first. So cosine starts up, so 0, 1. It ends up at 361, and it's down at 180, -1. And then 90 and 270 are on the midline. I'm going to do a nice broken graph here. And this graph right here, this valley, is going to help me create my shift, my horizontal translation of 45 degrees to the right. Since this is 90 degrees, this would be 45, right in half. So I can see that distance. I can measure this distance here. You don't have to do this, but I'm just showing you that distance. So every single point, I'm going to move that distance. So all of those, I'm going to move halfway over. I try to be consistent with my graph. So as soon as I see that distance, I try to remember that distance in my head and try to move all of those points. That one was wrong. All of those points over that same distance. And so now that I did that, I connect, and you can see I moved 45 degrees to the right. I'm not going to be picky with the 45 as long as it goes to the right. All right. The last one here, I've got a phase shift and a vertical shift. The vertical shift is 4, going up 4, so that's y equals 4. Amplitude is 1, period is still 360, and the phase shift is a -30 degrees, which is going to go to the left. Kind of went out of order there. So my vertical is 4. Make my vertical. Amplitude is 5 and 3. Make my maximum line and my minimum line. If you need to pause so you can catch up, that's fine. I'm going to label my period on the x-axis down below. So 360, 180, 90, and 270. I'm going to go ahead and graph the sine function as a broken guide graph. So 0, 4, 364, 184, 95, 273. Here is my sine curve, broken. There's the parent. And then I need to shift it to the left 30 degrees. So to go 30 degrees, that would be like breaking this into thirds. So I actually have to go into the negatives. I'm going to go over here. That point goes over into the negatives. This point would be about here. You just kind of use the graph and try to be consistent. That's all. Remember, we're only shifting to the left or to the right, so don't go up or down. So all of your points should still be on the max and the min lines and the midline. And there is my left translation 30 degrees. Notice how the guide graph starts below, then it goes above, then it switches to below. So if you try to wing it, it doesn't work. You need the guide graph. We're going to save the fourth graph for class just to work together. So for your lesson summary, I want you just to determine the translations of that function, and then I want you to graph that function so you guys can do that one. Give it a shot on your own. Good luck. I hope this saves this time.